Hello everyone, this is Dr. Zach. So for the next two lessons, you're going to review for a test on integration and derivatives, as well as those differential equations. So let's get started. So for today's lesson preview, did you remember to use logarithmic differentiation and the product rule as you worked on question A? And for question B, did you recall that once you wrote the equation of a tangent line, since you're playing with degrees, you needed to multiply by pi over 180 in order to remove the degrees from the problem? For the first group of questions, you're just showing me that you know how to integrate. So get to work on questions 1 to 6, turn the video off, and afterwards check through some of your answers. All right, so for number 1, don't forget that plus C. Doesn't matter how complex the problem is. Number 2, rewrite it using some algebra. Number 3, yes, let u equal 2x minus 3, and you're on your way with that question. Number 4, how about u substitution? U equals your cosine x. Number 5, rewrite it algebra first. That will always lead the way. And for number 6, if you let u equal your natural log of x, then du is 1 over x. Notice for the endpoints I've already substituted, they are u values. So when you integrate, you get your 2u squared over 2. Evaluate from 0 to the natural log of 2. You are set from there. All right, did you recognize for number 7 that you have an arctan problem? And number 8, algebra first. Have I said that enough? Use your algebra first. Number 9, I know you weren't tricked. You saw that this was the derivative of an antiderivative and busted it up into 2 parts. So I'm sure you did that. Oh, don't forget that you also need to multiply by the 2x if you're using a chain rule, and -1 if you're using a chain rule. For number 10, finding the general solution, notice down near the bottom, you have y squared equals 2x squared plus 25. Now, because y at 0 must equal 5, you only need the positive part of that square root. And lastly, number 11, pretty straightforward. Find your general solution and then substitute your values in to find the particular solution. For your next test, you are responsible for all 20 antiderivatives. So make certain that you know these antiderivatives before you take the test. Here are some strategies for integration that we've been working on. You should try to use some algebra in order to simplify the problems. Split the problem into 2 integrals if that will help you out. And don't forget how to complete the square. For u substitution, you should ask yourself, is there an x left after the u sub? If there is, solve for your x. Trig identities are very helpful when looking at integration problems. And always look at the structure of your problem. Is the denominator 1 exponent larger than your numerator? Then try to get a natural log. Is the denominator 2 exponents larger than your numerator? Then try for an arctangent. Is the expression under the square root? If so, think about arcsecants and arcsines. Use separation of variables to solve those differential equations. Double check that you remember how to make slope graphs with substitution and drawing those slopes as best you can. Look for patterns to make this a little bit easier on yourself. Now, of course, if you must know antiderivatives, you must also know the derivatives. So those have been listed for you. Strategies for differentiation. Know your rules. Know your rules. Know your rules. Oh, you can try to use algebra to simplify. Recognize the product rule, quotient rule, chain rule. Recognize implicit differentiation. Recognize when to use logarithmic differentiation. So you're going to take extremely complex expressions and use algebra to simplify them. Know that your derivatives of inverse functions are reciprocals of the derivative of the functions. And also know that definition for the derivative. So practice your derivative problems and then check on some of your answers. Turn the video off now. Do your practice. All right, fairly straightforward. Do you know your rules for your derivatives? Once again, are you using that chain rule? Can you work with your algebra very carefully? Don't forget a product rule as well. And lastly, the derivative of a product rule again. For number 19, did you remember to use log algebra before you found a derivative? And number 20, you were not tricked into saying e log x could be simplified. You definitely used a chain rule there. And number 21, did you use logarithmic differentiation in order to solve this problem? And number 22, more logarithmic differentiation. Well, look at that. It seems I did not tell you which point to write the equation of your tangent line. I hope you found the derivative of the natural of your log then. And for question 24, you found the derivative of f prime, and you knew that f at 1 was equal to 2. So f prime at 1 is equal to 5, and therefore f inverse prime at 2 must equal the reciprocal. The last several lessons have been very intense. We've had some new material, your inverse trig, you have to find antiderivatives, you have growth and decay. But while we've been learning the new material, there have been review materials embedded within the topics. Your next test has quite a bit on it. So it's your choice. The Unit 10 Lesson 6 follow-up is optional, but I have provided you with some excellent questions to think about. That's it for today. Enjoy what you do.